Alright, so in this part of the tutorials, I'm going to be covering loops. Loops evaluate a condition, and while that condition is true, they will execute the code contained in a set of braces. Of course, if it's just one single statement, you don't need the braces, but it's considered best practice to always have them, what's known as the block. And while you're making loops, you have to be careful not to create an infinite loop, which is a loop that has a condition that will always evaluate to true. And since there's no condition that ever becomes false, it just keeps running forever. Now, inside of Cloud9 or any Unix-based terminal, if you ever hit an infinite loop, hit Control-C. That will break out of the terminal. That'll tell the terminal to stop doing whatever it's doing, and it'll jump back to the prompt. So Control-C is your friend in the terminal if you ever hit an infinite loop. Now, there's two general formats for the loops. There's the for loop and the while loop. And then there's one special sort of quirky one. It's called the do-while loop, and we'll look at that one. The special use of the do-while loop is because the code in the do-while loop will always execute at least one time. So for a lot of programmers, when they write data input where they need to check it at least one time, they will use it to make sure that it executes. The other four conditions, if the statement is not true, then they just simply never execute. So the first one, the while loop, it looks like this. It's almost identical to the if statement. So normally it's if condition equals true, do this. The while loop is the exact same way. While some condition is true, do a statement. Now inside of that loop, it's going to need some way of turning the condition equal to false so that we can get out of the loop. So to look at this, the /while.exe, that is this guy right here. First, you have to initialize it. So int x equals 0, and while x is less than the value of 7, I want to print out the value of x is and whatever the value of x happens to be. Then I say x++, which is the post incrementer, and what that's going to do is that's going to increment x by 1, which will cause it to loop again. X will be equal to 2, 3, 4, so forth and so on. You can see that right here. Starts off, the value of x is 0, 1, 2, 3, 4, 5, 6. Once it hits 6, even though we've broken out of this loop here, we have not actually exited the entire program. So it prints out you have exited the loop, and then we hit the end of our main statement, and that's whenever we've actually exited the loop. The next one is the for loop. And the for loop has a major readability niceness to it. And the problem with the while loop is that first you have to initialize the loop somewhere outside of the loop itself. And then within the loop itself, you need to have some way of incrementing it or changing the conditions. That way, whenever it's finished running, it's going to do something different. So all of your pieces to this loop are scattered around. And if this was much longer, you can imagine looking around to see where all this stuff is. The for loop is very concise. It keeps everything right inside of its statement. But the syntax is a little trickier. So the first bit of code is the initializer. It's the initial value, and that's whatever you want to start off your condition that you're going to check. And while that condition is equal to true, it's going to execute whatever statement you have inside the body. And then finally, whenever it's through with that, when it reaches the end here, it's going to jump up and it's going to do whatever you tell it to do right here. And in this case, it should be something that will eventually turn this false, else you get the infinite loop again. Now the trick to this, and what makes it difficult to understand, is the first thing needs a semicolon. The second part needs a semicolon. But the third piece, you do not put a semicolon at the end of this. So to see it in action, it's for.c, and for int x equals 0, x is less than 7, increment the value of x. You see that in action, /for.exe. And it does the exact same thing as the while loop, 0, 1, 2, 3, 4, 5, 6, and then it prints out you have exited a loop when you exit it. So they're identical in a lot of ways, except that a lot of people find this concise statement to be better than this sort of scattered way. But they're in the same order, so first it has the initializer, then it has the condition to be evaluated, and then it has the post condition that it executes at the end of the loop. So they're actually in the same order, just one has it all in one line and in one place. Now the next thing is the do while loop. These are syntactically tricky, and they always evaluate at least once. So this do statement, that will always be executed at least one time. That is sort of the key thing to know about a do while loop. It will always do this at least one time because the condition to evaluate happens after it's performed whatever it needs to do at least one time. And also the other tricky thing about these is that this is the only condition that terminates with a semicolon. And the reason why is you have to understand the fact that C is white space insensitive for the most part. And what does that mean? Well, the way that C actually reads this while loop is like this. It reads it all as one line. In actuality, I need to delete all this stuff in order to get it all the way back. C reads it like this. Actually, any sort of statement, or excuse me, any sort of comment, C reads that as one empty character space. So this would be how C reads this, more or less like this. So in this part, you're not actually executing a statement here. You're actually just running right through and evaluating the condition. And so because C is white space insensitive, that is how it actually reads that. Now I'll put this back. And the reason why we write it like this as programmers is because we want this to be human readable. And when it's written like this, it's easier to see where things begin and end. You'll see these little dotted lines here. That's sort of telling you how this should line up. That it's not necessary to do this, but it's recommended that your beginning of a statement and where the statement terminates, they should line up. So your end should line up with this. So you can see how this opens here and ends here, and your while loop, its closing braces should match up with the while. That's strictly for human readability purposes, but as far as C goes, none of that matters. Anyway, in the for loop, it's got everything inside there. It doesn't end, but the do while, let me pop that open. Do while. This will first have its initializer and then do printf the value of x is whatever, and it will do it. Now, while the condition is less than 7. So let's change this. Let me say I set the value equal to 10. And then I'll compile that and see what it does. So hyphen do while.exe, do while.c, / do while. It prints out the value of x is 10. So even though the condition is false, it still went ahead and ran this at least one time. So we'll always do that at least one time. Again, a key point. When would you use something like this? Well, let's say that I have something where I want to check that the user inputs a certain character. So the first time through, I want to check that, and I'm going to print out enter C into the prompt. Then I'm going to get a value from them and store that into the variable C, the address of the variable really here. And then I'm calling get car. Why am I calling this? Because that'll hold the prompt for a bit. It'll make it wait until they do something before it exits. Otherwise, it'll usually run this twice. And this will execute while the value of the variable C does not equal the character C. So to run that, it says enter C into the prompt. If I hit A, nothing happens. 2, nothing happens. 9, nothing happens. M, nothing happens. Semicolon, nothing happens. C, it exits. So it ran it at least one time, and then so long as they don't enter that value, it never evaluates to false. What if I did it like this? If I just enter C into the prompt, it exits. So that is the advantage of it, is that it will make sure that something happens at least one time so you can check a certain value. Now, some programmers don't like this, and the reason why is because since C is white space insensitive, you can do something like this, and this is perfectly legal and valid. The problem here is it's hard to tell if this is a while loop or if this is a do while loop, because the do and the while are completely separate from each other. That's why you need the semicolon on this one and this one only to terminate the statement, because otherwise it will not know whether you're trying to do a while evaluation or a do while loop. And because it's syntactically quirky, a lot of programmers don't like it. So if you do happen to not like it, there are other ways to get this same sort of functionality, which we'll check out in just a second. But first we'll talk about the continue statement. The continue statement, if you use it, the loop will keep running, but it will execute a special condition whenever it's reached. So to see that in action, here's continue.c. It's the same loop. It'll execute so long as x less than 10, but whenever x is equal to false, it will print you have reached a continue point. The code will keep running. Anything else, it just prints out the value of x. So / continue. Oops. 0, 1, 2, 3, 4. When it hits 5, it evaluates the continue point, and then it prints out 6, 7, 8, 9. All right. And then when it's 10, it exits. Oh, I see what happened. I accidentally wrote inside of here. Now, that's the continue loop. It just lets you execute a special condition while x is equal to 7. And of course, a better way to use it would be if you wanted to get some input from the user whenever x is equal to 7 or something else, and then when they do it, you continue with the rest of the loop. Now, the other version of this you've already seen before is the break statement. You saw that in the switch, that if some condition evaluates to true in the switch statement, then break out of the entire thing. And that works the exact same way here. So inside of my break.c file, I have for x equal to 0 while x is less than 10, increase the value of x, but each time it's going to do it, it's going to print the value of x. Now what's going to happen here is that unlike inside of the continue statement, when it kept executing past here, it ran 6, 7, 8, 9, past the continue point, and the break statement is going to run up until 5, and then it's going to stop. And then I have one other function that's called, and basically it says, even though we're out of the loop, we didn't exit the entire program. So this only breaks us out of this for loop here. It doesn't actually break us out of the entire function. So / break 0, 1, 2, 3, 4, and then it says you have reached the breakpoint. This will break out the current loop. So even though x is not greater than 10 or equal to 10, it still never evaluates this. It's done with it once it hits the breakpoint. So it breaks out of it, and then we print our little function that says even though we're out of the loop, we didn't exit the entire program, and then it takes us back to our main prompt. What if you do want to exit the entire program? This is usually used whenever you want to check if something is an error. So if something goes horribly wrong and you need to exit the program, you can use the exit keyword to create a condition where you test it, and if the condition comes true, you say stop everything you're doing. That is the exit keyword. To see that in action, it's exit.c file, same for statement as before, where we now have to include the standard library.header, and there's a lot of useful functions in this. The standard library has lots of good things to check out, but for our purposes, we're only using the exit statement. So now whenever it reaches the exit point, that print function that was executed with the break statement, that will never run. So / exit.exe. Oh, I didn't put the exe on that. So just / exit 0, 1, 2, 3, 4. Then it says you have reached the exit point. This will exit the program. It calls exit, and it actually completely jumps out of this entire program. So that's the difference between the break statement, which will simply keep executing, and the exit function. Now, we got back to the problem with the do while, that some programmers really don't like it, so they wanted to invent another way of doing it. So they created something called forever loops, and basically the way they work is use a for statement and then 2 semicolons. This is the minimum valid for statement. And this condition never gets evaluated because there's nothing to be evaluated. So it will execute a statement, it will then perform some sort of condition check, and if the condition check is equal to true, you call break, and that jumps out of the for loop entirely. To see that in action, we have the forever loops. It's the exact same thing as the do while, but this time it's going to ask to type in the letter C, and then it's going to scan in that value, and if the exit character is equal to C, it's going to break out of there, else it's going to print if you did not enter the C character. So / forever loops. It says please type in the letter C. If I type in A, it's going to print out this else statement. You don't enter the character C, the C character, and then please type it in. And for as long as I keep not doing that, it doesn't execute, or excuse me, it doesn't break out of that loop. But when I hit C, it exits. So this is a way some programmers get around having to use a do while loop, because this executes at least once, it checks the condition, then it breaks out of it once the condition turns true. Now the other way of doing this is with a while loop. And as you remember, 1 equals true, or actually any non-zero value equals true inside of C. So while 1, so while something is true, statement 1, condition check, and if that condition check is true, break out of there. Now, why use the weird kind of looking for version of this instead of the while statement? Memory efficiency. The while statement will always actually evaluate. The while will see if 1 is still equal to true each and every single time, which means that the more times you run this loop, the more inefficient it becomes. The more this for loop, which never actually evaluates, it will just keep running forever. This one will actually attempt to execute and actually attempt to check to make sure this is true. I don't know if I wrote one like that. I don't think I did. But you can run it yourself and you'll see what it does. So that's how for loops work. And these are the different control points. You have your while loop, while something's true, do something and then make the condition become false at some point. Your for loop, initialize, check, and then do some sort of increment. Do while, do something as long as this condition is true. Continue to make the loop keep running, but also to but not to break out of there. Break when you want to break out of that loop, but you don't want to exit the whole program. Exit when you want to completely exit everything you're doing at that point. And then sort of the quirky forever loops.